a square of side length S, which is the black square in the circle, is inscribed in a circle of radius r. Write the first part, write the area of the square as a function of the radius r of the circle. So usually when I'm drawing a radius, I start here and I draw it out to there, and that's okay, but that doesn't really help me figure anything out about the square. So really, if I'm doing these inscribed circle and square problems, I want to look at the radius as that. Now I can probably figure out the length of each side in relationship to the radius. So now what I do know is I know that the area of the square is equal to s squared, s times s. And if I draw a line like that, I know I have r, and I know that this distance right here is 1/2 s, and I know that this distance here is 1/2 s, because it goes from the center of the square, which is also the center of the circle, to the edge. So I know that by the Pythagorean theorem, 1/2 s squared plus 1/2 s squared will equal r squared. That's a squared plus b squared equals c squared. So this gives me 1/4 s squared plus 1/4 s squared equals r squared. So 1/2 s squared, adding up the two 1/4s, equals r squared. And if I multiply both sides of this by 2, I get s squared equals 2r squared. Well, guess what? My area is equal to s squared. So my area of the square, so I'll put area SQ here to distinguish it from area of the circle, is equal to 2r squared for the radius. That would be the answer to A. That is the area of the square as a function of the radius of the circle. So I have A equals 2r squared. A equals 2r squared. Well, now that I know that, find the instantaneous rate of change of the area with respect to the radius. So basically find the derivative of the area. So A prime would equal 4r. That's the instantaneous rate of change of the area with respect to the radius. And what is it when my radius is 1 or my radius is 8? Well, A prime, let's call it of 1, would equal 4 times 1. So the answer to that is 4. And A prime of 8 should equal 4 times 8, which would be 32. So I'm pretty happy with those answers. Now the last part here is dealing with units. And units are important in calculus because a lot of times we're measuring things that are real. We want to know what the units are. So my radius is in inches, and my area is in square inches. What units are appropriate for the derivative, that is the rate of change of the area with respect to the radius? Well, it would be, so for example, this, the rate of change is, the area is changing by 32 square inches per every inch of the radius. So the units would be square inches per inch.